This is Andrew Turner, Co-Organiser of the London Test Automation and DevOps Meetup group. Welcome from London. We have some great speakers on today. Thanks for all the people that are joining the webinar from wherever you are in the world. Today we're going to take about an hour and a half to cover three great speakers, one from San Francisco, one from Auckland in New Zealand, and one from London. I'll introduce them in a second. During the session, we're going to have some webinar logistics. So we're going to be using Zoom webinar as you've kindly registered for today. We're going to be recording this session. So we're going to have to be able to make that available after the session has completed in the next couple of days. During the session, all people will be muted, but you can submit any questions you have through the Q&A button, which is actually should be on the bottom of your screen. So we'll run a Q&A session during the session towards the end, before the wrap up. And so any questions or you've got for the speakers, we can run a Q&A as we run through the presentations later on. So in terms of our speakers today, we have myself. I do a few things today, and one of the things I do is I run a podcast on YouTube called the G&T Sessions. People think it's about gin and tonic, but it's about growth and technology. So I've been running that for a while. We also have Philip Lew. Philip, do you want to introduce yourself?
Good morning or good evening, everyone. My name is Phil Lew, and I'll be talking about how to not become irrelevant in the age of AI and testing. So I'm really looking forward to talking to you guys.
Thank you, Phil. And then we've got James Farrier from Appsurify. James.
Hey guys. Yeah, I will be talking about, what will I be talking about? How we use AI to actually improve your testing.
And last but not least, Mr. Ian Sharp from Slalom.
Yeah, thank you, Andrew. Good morning, good evening, good afternoon. I am head of Responsible AI Enablement at Slalom, and I'm going to be probably coming at it from a slightly different perspective as a data scientist. So really sort of talking about some practical use cases for AI and testing. So thanks for joining tonight.
Okay, great. Thank you, Ian. So in terms of the why we are here, as we mentioned, we've got quite a good community globally, and obviously predominantly based in London around this topic area. So we're going to cover just a bit of a segue before we actually get into our speaker presentations. So some of you may be aware that Shashi Jagtap originally founded this meetup group a number of years ago. It was originally based on some discussions around things like Selenium, and he's really running it for a number of years. A couple of years ago, I got involved in the group, and we've now got nearly 3,000 members, just about 65 people below 3,000 members. We normally do about 3 or 4 physical events per year, and this was going to be the first physical one we're going to do in 2020. And obviously now moving to more of an online format, given the current situation with the pandemic. I hope everybody's safe and well with their families. We don't currently do any sponsorship for this meetup, although we've been approached by a number of different companies, but open to discussions during 2020, if that's something of interest for people to talk to us about. And obviously, given that we're going to be changing this format to be more of an online session, what we've been talking about internally is about, do we maybe run an online meeting every 6 to 8 weeks, or even more frequently, potentially, if there's some interest. So if you've got any particular interest in speaking or participating in the community and sharing some information or sharing some knowledge back into the community, then please contact me directly on my usual email address, andrew.j.turner@mac.com, and we can talk about involving you in the future sessions that we'll be planning through 2020. And obviously, hopefully, soon into the future, we'll be moving to more of a physical, back to a physical meeting in the London area. So, why are we speaking today? Classic quote from Mark Andreessen. Spoke many years ago before he formed Andreessen Horowitz. He was obviously one of the co-founders of Netscape, which was one of the first browsers in the world. So software is eating the world. There's a context of that being software, every business being a software company these days. and just put my email address in the chat. There you go. So in the context of that, if you think about organizations today, people are looking at how they engineer software and how they build software into their operating model. So it's a very interesting quote and very relevant these days about how we actually operate as organizations, even to people like the things that Elon Musk has done recently in the last few years, where you actually upgrade your own software to run your Tesla. So in terms of actually then the evolution of that, as we probably have heard in the last few years, I don't know if you've come across this guy, Jensen Huang. He basically was the founder and CEO, and still the CEO today, of NVIDIA, which obviously started back in the early 90s, 1993. And they are the driving force behind the GPU. They created the GPU, the graphics processing unit, which now is obviously built into things like MacBooks, think about MacBook Pros, iPads, Android tablets, etc. And obviously they've been working very significantly more recently with building things like the Turing architecture, which builds things like the supercomputers of the future. So his quote obviously is a context of software being eating the world, but obviously AI is going to eat software. So that was back in 2017. So when you talk about what we're doing today, and obviously we've got a bit more time on our hands, I was doing some research around interesting books that people should think about reading if they want to do some future reading about AI. And these books came up as something to think about if you've not already read them. The one on the left is particularly personal, given what's been happening over the last couple of months and weeks recently, as it's been obviously developing about the what's happening in China, what's happening in Silicon Valley, how that's responding in the US, and obviously the new world order of how AI combines with that. Obviously the human and machine interface. So how do we use machines and how do we have human oversight for what we do with software and machines and robots and smart vehicles, etc., autonomous cars. And then I don't know if anybody's written or read the book around that Nicole Forsgren and Jez Humble wrote with Gene Kim, but obviously that's a more recent document about the way that kind of progressive organizations are using to accelerate their software delivery cycle. And the reason I mention that one is because obviously whatever you do with a machine, with data, and with software, you still need to think about how you underpin that delivery. And obviously what the research that Nicole and Jez Humble did, who now work for Google, although I know Nicole has just recently left Google, but is about actually how do you actually build that process into an organization. And actually as part of the software engineering lifecycle, obviously testing is a critical part of that. But a lot of focus has been over the last few years about how do you re-engineer the development cycle, right? How you create the code, but a lot of areas still are still open to actually improve how you actually do the testing process. So obviously today what we're looking at is talking about testing, talking about AI, talking about how the best practices of the people that we're talking about today and our speakers, how they can share their knowledge and share their insights from working in the field with large organizations. So to our speakers, what I'd like to do now is hand over to Philip, and he's going to take you through the next 20-30 minutes to cover what his experiences are from being originally, it sounds like a technical background, and now running a very prestigious organization over in Silicon Valley. Over to you, Philip.
Thanks, Andrew. Let me see if we can get this screen sharing thing working here. Here we go. Let's see. Okay. Alrighty. Well, today's talk was actually going to be a live talk on or about this time, but we decided to travel virtually. And the title of my talk is Don't Become Irrelevant. And I think that AI is definitely one of the topics that's very, very on the top of people's minds besides the virus. And one of the things I thought about was the old cliche was working smarter, not harder, but I think we need to do more than that today. And that includes grasping new technologies and thinking about totally different ways of doing things. And AI is part of that. A little bit about myself. I founded a company called XBOsoft over 10 years ago. And the only thing we do is software QA, consulting and testing, which you might find interesting more than my professional background, which you can find on LinkedIn, is that I love cycling and travel. And you can see from my background that there's a desert background there, and that's from Death Valley. I was just there a few weeks ago before the whole stay and shelter in place order came about in San Francisco. So now I'm here stuck in San Francisco, a really bad place to be, but I'm glad to be here today. So let's talk about how we got here in terms of to this AI world and paradigm that we live in. It started, say, 50, 60, 70 years ago with the advent of the mainframe. Actually, AI algorithms and was already invented at that time, but it wasn't really able to be realized because AI is so data intensive and processing intensive. Then we had, of course, the advent of the IBM personal computer back in the 80s. And then telecommunications went digital via fiber, which enabled us to move data around. So that's the first step in AI, is being able to move that data around very quickly. Then we had things like mobile phones, and in particular the iPhone, which came out in 2007, which began to start creating that data. All kinds of data, as you know, are collected on the mobile phone and captured via a plethora of sensors on the phone. So we have a bunch of data, and then we started having all kinds of IoT devices, including the wearables and different types of things that, through the use of Bluetooth, are able to capture and transmit data and collect it via the cloud. So then we have another technology which was brought about by increases in computing power, along with cheaper methods for storage, which brought about usage of the cloud. They're all kind of came together, and now we have AI, which uses that data and processes it. And with the recent advances in quantum computing, I see there's just going to be a huge momentum going forward with AI. And that includes for us in software testing. Just a little bit of background about AI. When I first started looking into AI, I asked a friend of mine, do you guys use AI or ML in your development process and software testing? And he said, well, you must not know anything about AI or ML, because all you need to say is, do you use AI? Because ML is a subset of AI. And I thought, oh, okay, I guess I better start learning a little bit more about this stuff. And so this slide here just kind of gives a snapshot of what machine learning and deep learning are relevant to AI, in terms of AI actually behaving and thinking like humans, getting machines to do that, and ML training machines to improve and learn on their own with more data. And then, of course, you see the deep learning, which is using neural networks and different ways of learning to increase the intelligence of AI. And I started to think, okay, so what is the difference here? And when I looked on Google, I found that machine learning is actually more popular and more demanded in terms of what people are searching for. And I thought this was interesting. So I thought, okay, well, let me look more into machine learning and what that really entails and how that can affect and improve the development process. I also looked at, of course, the Gartner hype cycle, trying to figure out what people are doing, how this applies to us as software geeks. And you can see that the automated ML, machine learning, natural language processing, those things are either at the top of the hype cycle or starting to go through what they call the trough of disillusionment. You see that things like data labeling, which is the categorization of data and figuring out what data is all about is on the upswing. And that's one of the big, I would say one of the bottlenecks of AI is getting that data and understanding the data. Because just like the old saying, garbage in, garbage out, if you don't have good data and have clean data and meaningful data, then it doesn't really mean a whole lot for AI. Of course, you see computer vision, and computer vision is one of the big things for test automation in terms of recognizing objects. And you'll see that we're getting close to the trough of disillusionment. So this is going to be really interesting going forward. I know some of the other speakers are from different backgrounds that actually make tools which do test automation. And I think a lot of the test automation work for some of these tools is about recognizing objects. We did do some trials in working with different software, and we did find that there was a weakness in recognizing, not only recognizing the objects, but learning how to recognize objects and teaching the algorithms to recognize objects correctly in a consistent basis. So what I'm going to talk about today is some of the problems in software development and testing that we have. And then next, talk a little bit about AI and how they can apply to those problems. And lastly, I'll talk about what I call the silver lining, which is opportunities for today and tomorrow, given the situations that we have currently. Like I said, working smarter, not harder is not enough. And we need to get better at building quality software. And so when I think about it, I think, so how do I break down the software quality and software testing process? And I think that any of these areas are ripe for using AI and adding intelligence to software testing. So, you know, how do we determine where to test in terms of test planning? Well, you can use AI to analyze data to look at where should we be testing. The same thing with designing our tests. What kinds of tests do better than others in terms of identifying problems? And then looking at test results, analyzing those test results to figure out where we can get the most bang for our buck in the testing. You can see that our test coverage has a dimensional explosion. You know, that if you look at, you know, how can we generate tests? Well, we can add more people. We can add more automated tests. We can add more people that add automated tests. But that, again, is linear, right? So you can only add so many people. You only have so many hours in the day. And so our goal and what those that are using AI and their tools are trying to get around and get up in front of this explosion. And it's really a not just exponential explosion, but really an explosion of the nature of the power function, which increases the exponent, you know, 10 to 20 times. The question is, how fast can you generate tests, and how fast can you generate good tests, whatever those are, right? Another problem we have is that we just don't have enough people. We don't have enough skilled people with the right skills, and sometimes learning how to do testing or learning how to do automation is a problem. Not only that, working together, personalities, attitudes, etc., those contribute to some of our demise in developing quality software. Writing code, writing tests, it's a hard thing to do. Like I said earlier, you have to be properly trained. Sometimes they can be difficult, and we all make mistakes. Maintenance and scale. So, you know, you've all heard about test automation code. It has to be maintainable in terms of not only recognizing the objects from the get-go, but also being able to adapt to objects that change names or change shapes or change locations. And who has the time to do that stuff? Now, I put this picture of a lawnmower here because I would bet that less than half of the folks on the call today, on the webinar today, mow their own lawn. Because why would you want to mow your own lawn? You just, oh, we just want to get somebody else to do that. It's dirty. It's something you don't want to do. You got to have special equipment. A lot of people just don't do it anymore. That includes cleaning your house and so on. And so I think that maintaining automation code is very much along the lines of mowing your lawn. It's just something that you just don't want to do, and who has time to do it? So you want automation code that can maintain and fix itself, right? Another problem with computer vision and what object recognition is, you know, like I was saying, that these objects can change locations, they can change names, they can change a little bit of their functionality, some of their attributes can change. So being able to recognize the objects via more than one attribute is really, really important. And being able to understand when attributes change doesn't necessarily mean that the function of the button changed. So that's really important for us to be able to figure out with AI as well. So here's just a little bit about where AI is used today. As we all know, facial recognition, autonomous driving, things like that. And this is a slide borrowed from Diani, one of my colleagues, where he mapped this out in terms of being able to get training data into a machine learning algorithm. Then you use that and develop a model and implement that algorithm. You do some predictions and evaluate whether or not you were able to do a good job. Evaluation could be yes or no, yes, I was right, or I was wrong. And I'll go over that soon in terms of looking at the different types of machine learning. And then of course, recognizing that input data and training data is one of the critical elements of a successful machine learning algorithm. So here's just a kind of a synopsis of machine learning defined. I call it AI 101 in terms of getting a machine to learn without being programmed. That's hard to do. And so the way it was defined by Tom Mitchell about 20 years ago is a computer program is said to learn from experience E with respect to a task T and some performance measure. If its performance on T as measured by P improves with experience. Now, this is kind of hard to understand on a conceptual basis, but if you put it in real terms and you think about it like this, if your email program looking at spam watches emails you do or do not mark as spam, and based on that learns how to do better filtering, then you can kind of phrase that in terms of what is T, what is E, and what is P in terms of the performance measure. And so the experience is E watches emails that you do or do not mark as spam. And then your mark as spam, that would be the measure of performance, spam or not spam. And then the filtering of the email is actually the actual task that the machine is trying to do. Going on with our short machine learning primer, you know, when I was learning about AI, I said, okay, well, let me try to understand how this works because I want to be able to apply it intelligently to testing. And you can see that there's two types of machine learning, supervised and unsupervised, and there's further classifications of these types of learning as well. And I'm going to talk about these in a second. So the first type is supervised learning, and this example comes from Coursera. You know, supervised learning would be something like you take housing prices and you look at the size of the houses and the price that they sold for, and you can do a regression in terms of learning what the price should be based on past data. So if I have a house that I'm about ready to sell and it's 119 square meters, and then it should be approximately, say, $210,000, $220,000. That's called regression. It's called supervised learning. So based on this learning data set that you would put into your ML algorithm, it could come out with some type of predicted price on a graduated scale, right? And so eventually you would predict the price, and then you would have the real price, and it would start to learn, okay, based on this factor, it's too high or too low, right? And you get a continuously valued output, the price, that has increments, very, very small increments, right? You can see that on the scale here. You have whether it be 122 meters or 144 meters, you can still get an output. On the other hand, we have supervised learning. Supervised learning is about classification. And so you can see here that, for instance, you have tumor sizes, and determining whether or not predicting, right? We're trying to predict here, use machine learning to predict whether or not a tumor is malignant or not. And you can see that, well, okay, if the tumor is small and I'm putting in these data points, okay, it was not malignant, it was benign. And then if the tumor has a certain size range, well, then more than likely it's going to be malignant. And so you have these inputs of sizes and then outputs and of real data in terms of malignant or not, and you can develop a prediction algorithm to determine whether or not the tumor is malignant. That's called classifying, right? So it's malignant or benign, yes or no. It also is not limited to 0 or 1, yes or no, but could be a discrete valued output anywhere, you know, as long as it's discrete values that you have as an output or a possible result. Transforming this down to putting it all on one line, you can see I put all this data on one line at the bottom. This gets us to our next type of machine learning, which is about classifying in a different way. So you take groups of data and you classify it in terms of tumor size and maybe add another categorization or characteristics such as age, and then you can kind of add more characteristics into your data set, right? And then you can say, okay, well, what other data attributes or characteristics of these tumors should I consider? Well, I could consider the cell size, cell shape, the hardness of the tumor, many other characteristics that I can think about. And you can see how this two-dimensional matrix or two-dimensional graph here could become many dimensions, and therefore you would need some type of machine or algorithm to process that. So let's do a little quiz here. If we want to examine all priority 1 defects and predict how many will get fixed before the next release, what kind of a problem would you think that would be? Would that be a classification issue that you could use machine learning for, or would it be regression, right? And the same thing for if I wanted to examine each defect and decide if it is priority 1 or priority 2, would that be a classification problem or a regression problem? And so now you can kind of start to see where these machine learning concepts can be transported into our daily work as software quality folks. So let's look at supervised learning now, or unsupervised. And unsupervised learning is really all about clustering, pattern recognition, making some kind of sense. Oh, we got making some kind of sense about the data. So getting to object recognition. What type of machine learning of object recognition is object recognition? Well, obviously it's a classification issue, right? It's a classification issue with many different discrete level outputs. Let me see if I can, there seems to be a beeping here. Looks like there's a chat. Let me see if I can. Okay, I don't understand the distinction between classification and regression here. Well, okay, maybe we can get to that later, I hope. Okay, so maybe I can explain this here. So in other words, if I'm doing a object recognition of these objects, it's either a mouse or it's a handbag. It's not something in between, which would be regression, which would be half handbag and half mouse. So, and the same thing with a tumor, it's either benign or it's not. Whereas a housing price, when I put in a bunch of inputs, it could be, it's not 240,000 or 300,000, it could be anywhere in between. And that would be a regression. Hope that it clears that up. Let's see here. Okay. I think I'm going to skip over the slide, but this is really the same thing where you apply AI principles of software testing. You have a bunch of inputs, you put them through some type of models and training and development. And inputs are data, basically. Data such as what type of test it is, what function you're testing, whether it was passed or failed, the past information on the actual test case, and so on. And then you get an actual versus expected result. So anyone could talk about AI, but what about QA and testing? What problems can we solve? I've gone over some of the issues in terms of prediction. Test automation, we can certainly get a lot better and faster and reduce the maintenance effort. But the real question to me is, since I run a software testing organization, is how can we increase our defect detection and reduce defects in production for our clients? And of course, the bottom line is the software ready for release, right? Is the software ready for release? That could be a regression problem. When I think about it, it could be the probability that it's ready for release is definitely a regression. It ranges on a scale, right? From 0 to 100%. Or I could consider it a classification problem where it's 0, not ready, or 1, ready. So the problem about applying, and I'm going to go through some of the issues in applying test automation, AI to test automation. The problem is that it's labor intensive. Finding and discerning objects is an issue. Changing the attributes, and of course, recognizing and teaching the algorithm to learn is it's not exactly that easy. I mentioned earlier that we tried on a couple of different products, and we had difficulty in the accuracy, but more important than the initial accuracy is training the algorithms to get better. Test generation, there's the problem of collecting real good user information to actually generate the test because you want to simulate a real user, right? So that's definitely an issue in aggregating user flows and creating these test cases. Machines learning from humans. So you could have a machine mimic or try to think like us as software testers, getting information from us, but observing what we're doing, getting the input, having a test oracle, and also making your algorithm more generic rather than specific to a certain application or page can be difficult. Here's some of the things that AI can do in terms of writing better code. This is a video from a large internet company in China. And you can see that what they do here is they're actually using autofill to help their developers make better code, analyzing each developer's mistakes that they've made in the past and helping them to autofill and complete their code in a better way. Is another one where they actually develop developer profiles. The profiles of a developer could be the errors that they've made or the bugs that they've found that are related to that developer, and analyzing those defects for that developer and being able to help that developer to make better code. Other ML applications, like I said, was in prediction, focusing on where to, analyzing defects as input and being able to predict where defects will occur and so on. So what type of machine learning algorithm can we use for these things? I think you could probably figure that out from today. But wait, there are some issues with machine learning and artificial intelligence in terms of analyzing the data. And so let's take a closer look at that right now. So we have a lot of natural ways of thinking about data. And I put this tiger up here because naturally, we as human beings, if we hear something in the bushes, we might naturally run, right? And so AI is supposed to help us get over these natural intuitions that we have and say, okay, well, let's take a bunch of other inputs besides noise in the bushes, and maybe it's not a tiger, right? And so taking all this other input in, will help us to get over the biases, and hopefully AI is supposed to help us with this. There are a lot of cognitive biases that we have. I won't go over them. I just thought about one the other day. I was washing some clothes in terms of anchoring. You know, when you fill up the little cup for laundry detergent and it has a line on it, they have actually anchored us into thinking that we need this much detergent. but maybe we don't. So I started doing some experiments, putting in a little bit less or a little bit less and seeing how much really do I need to get it clean? But they've anchored us to think that we need a whole cup of detergent. Well, I don't think we really do. So there's a lot of these different biases that we have. And the thing is, AI can help us with these. Here is a list of biases. I'm not going to go over them, but you can use this later and use it later for reference. You'll have copies of the video. I talked about machine learning issues, one of them being classification and spam or not spam, right? And so deep fakes is one of the areas that that people are working on Google in terms of getting in a data set. Is this real or is it fake, right? And so there's different types of characteristics. You can see that's a classification issue. What are the attributes that they would feed in to determine whether it's fake or not fake? You can see that multi-dimensional matrix in terms of the characteristics of the data to determine fake or not fake. Is this supervised or unsupervised? I'll let you guys answer that. Another one, everybody's seen this, where they have problems with facial recognition and misclassifying a photo as a gorilla because of the dark skin. And so the same thing with autonomous driving. I start thinking about, okay, so what kind of data is needed to make the data set complete and dependable to avoid crashes? Lastly, there's the issue of silent data. You know, this is taken from some research I did on turkeys. You can see that they need 45 months to grow to full size, 16 weeks to get to 7 kgs in weight. That's really fast. And all along this time, the turkey is eating every day, having a great life. Little does he know that suddenly he will turn into Thanksgiving dinner. And so the question is, what can we learn from the turkey? Well, the turkey obviously doesn't have the data that soon he will be eaten, right? And so the thing is, just because you don't know doesn't mean it doesn't exist. And so I got this thinking from Nassim Taleb's book on the Black Swan, really, really interesting book on the concept of data that is silent, and that the proof of burden of proof, where does that lie in terms of whether or not it exists or not? And that really gets to the heart of AI. The heart of AI is in the data, and we have to be really thoughtful and careful about taking the inputs of data, like I said before, garbage in, garbage out. And so now I think you can think about, you have enough background to think about the different types of machine learning and how you can trick AI, I think. And I'm going to get to today and think about, okay, so we know the weaknesses of AI and machine learning. We know what it can do. It's scary out there, right? Here we are today with COVID-19. You can see from my profile shot versus today, I can't even get my hair cut, so I put my hat on because I can't get a haircut. What does it mean for us software nerds? So one thing I thought about is that the world has really shrunk. Our leaders are really preparing for the wars of yesterday. And so viruses, they can jump over walls fairly easily. Tanks have no effect on viruses. And here we are, shelter in place, like I said, no haircuts either. And so because the world has shrunk, other countries, what we thought was their problem is now our problem. It's a world problem. I think there are a lot of world problems today that we try to tackle or not tackle as a country, which is definitely the wrong way to go. So we have the old world, right? We as businesses and humans want to come together. And you think of all these industries and all these things that are dependent on us coming together. Andrew mentioned earlier about, oh, we're going to return to physical meetings and so on, and our next meeting and so on. And, I'm not really sure about that. How much will that return? It depends on how long this goes for and how long it can actually change our paradigms and our ways of thinking. You think about all these different avenues that depend on people getting together. The NBA season was all canceled, right? Conferences are canceled. Gyms are canceled. Everything is closed. And so I think about, okay, the world, the new world, post-corona, the new normal. I think that viruses are the weapons of tomorrow, both biological and in terms of computer and network security. Driving for automation, robots, they don't get sick. So I'm sure that Amazon is working even harder now towards automating their warehouses. And there's this whole thing about working at home, or WFH, working at home, working from home. And I think that especially the working from home is going to change big shifts in the way we work. And of course, there's collateral damage. I'm looking at my retirement fund, which used to be what's called a 401k, and now it's a 201k, right? So elderly folks, people that are thinking about retiring soon, they're going to have to rethink that. Many things that are going to be damaged because of the situation that we're in today. But here are some bright spots. So you think about the drive for automation, working at home. What's going to happen? Okay, so we're going to have a lot of opportunities in remote healthcare, a lot of opportunities in no physical banks, having a cashless society, moving more towards mobile payment. What kinds of software opportunities are those going to create for us? And the same thing with education. I think people are going to discover, well, I can get an education without sending myself or my son or daughter physically to a college. How can I do that? And the whole, what I consider the office infrastructure reset. Let me see here. Yeah, I'm almost done, Andrew. Almost done. And so so a lot of these opportunities here, and it's going to create an increasing demand on software. We're going to have a lot of new business models, a lot of new software opportunities, and all of these things are going to be built in with AI into the business model and into the future. And so I think our crisis has a silver lining. I encourage you to learn as much as you can, not only from today, but continue develop a learning plan on what you're going to learn today and tomorrow to prevent yourself from becoming irrelevant. And here's an open source libraries for reference, which you can have later. Here's some reference lists and learnings and folks that I've learned from and asked lots of questions. My dad used to say to me, don't ask so many questions, it's because I said so. Well, I think you should still ask lots of questions. So that's all I have for today. Don't become irrelevant, and I hope that you're ready for the new world. So I'll stop sharing now and I'll give it back to Andrew.
Thank you very much. Thank you very much, Philip. Interesting session. I think we're now going to pass on to James. So James is going to pick up the gauntlet now and run with it. But really, really useful, educational, and very topical. So thanks for that, Philip. James, are you ready to present?
Yep, you can hear me.
So we're now going from San Francisco to Auckland in New Zealand.
All right.
Over to James. Thank you.
Cool. Thanks, guys. Yes, it's a little bit early for me. Like Andrew said, I'm from Auckland, so I got up early. If you hear my wife snoring, it's because, you know, it's early and we don't have very much to do here. We're sort of locked in quarantine. So I studied software engineering at Auckland. And at the end of that, I got my first job. It was in SQL Server development and Java. And then at the end of that job, it was nearing the financial crisis and things were starting to slow down already. And so I had moved, they asked me, what do you want to do? And one of the roles that they had open was a test automation role. And I thought, this is great. I'm going to automate all these people out of jobs. I'm a little bit of an evil person. But then what's happened is for 12 years, I've been trying to do that. And for 12 years, I've failed. It turns out that test automation is a lot harder than what I originally thought that it would be. And so I've founded Appsurify essentially to, you know, solve some of the problems that I've seen as I've been in test automation and testing. and to go to what it's actually going through a lot of what Philip was talking about. So it's ways of essentially improving the way that you do testing, making you test smarter so that you've got, I guess, more time available. So you don't want to be mowing that grass. So the reason why I started this was because at least the companies that I was working with at the time, they were transitioning from waterfall to agile, and they were having a tough time doing so. So they were, waterfall, they had 3 months to do their testing. Suddenly with agile, they've got, 2 weeks. And with continuous integration and continuous deployment, oftentimes the manual testers had even less involvement, but they were struggling to find a way to, the term is shift left. How can they test earlier in the cycle? Just want to make sure that everything is all right. Yeah, so how can they test earlier in the cycle without releasing defects? And a lot of the time that comes down to having automated testing, or given that Michael Bolton is in the chat and he'll yell if I don't say this, automated checking. And how can we get the testers involved earlier? How can they be involved in the documentation, the requirement gathering, and really shift their focus to, and then like there's this as well, which I think is pretty spot on. How can we test throughout rather than at the end? And how can we prevent those bugs over finding them at the end and finding them in production, which is obviously worse. And the other thing that I like in this is really how can it become a team responsibility over just being a tester responsibility. If a developer is releasing code which is not at all tested, then it seems to me that this is not a tester problem, it's a team problem. So to shift left, to start testing throughout, again, everyone's moving to continuous integration, continuous deployment. What should that look like? And most of you are probably doing this type of thing already, but hopefully this works. Okay, so a commit comes through and, developer's done some work. The application gets built, and then there are some unit tests run. Hopefully the developers have written these unit tests. I apologize if there are a whole bunch of developers in the webinar. Then we'll run some API tests, maybe some contract tests. I guess it completely depends on the application that you're building, and then maybe even some UI tests. And so you can see the build is, quick. The unit tests are quick. The API tests are maybe a little bit longer, and then the UI tests are a little bit longer after that. And then we deploy, and then maybe we have some time to run some manual testing, some exploratory testing before we end up doing a release. And then of course there are no bugs, and everyone goes home. And if this was the case, probably wouldn't be much need for my talk. But what I want to highlight is this area. This is the time where you really need this to be under, let's say, 5 minutes. I'd prefer under 3 minutes, because developers, they don't want to be waiting for these builds for the output of the continuous integration system. It's going to cause them to, take breaks, to move off the task that they're doing. And to prove that, I found this fact, which amused me greatly. The first webcam, that someone ever set out and put on the internet was actually just to watch coffee boil. So I always joke that, the longer your CI takes, the more coffee breaks your developers are going to take, the more caffeinated they're going to be, and thus the more mistakes they're going to make. The other thing that might happen if you've got a long period in your CI is they're going to go play table tennis. And this is a disaster, because then the testers will not be able to use the table tennis table. And then the other option is they're going to take a nap on their desk. Now that they're working from home, this is probably even more likely to happen, unless they've got kids, in which case they're probably being yelled at by those kids. But what's actually worse, and what I've noticed a lot, is that they'll start context switching. So they'll be working on one task, they'll do the commit, they'll expect that the UI tests are going to take, 2 hours to run, and they're going to move on to another piece of work. And when they move on to that next piece of work, that's when they're going to suddenly, they're going to be in the middle of the change. They're going to have spent 30 minutes looking at the task, 30 minutes reading the code, and then another 30, 40 minutes starting to make a change, only to have the results of the CI system come back and inform them that there was a bug in their previous change. And that's when they suddenly have to be like, okay, I'm going to stop doing, I'm in the middle of this change, but I'm going to stop because I have to go back, revert my code change, and then go back in and make a fix. And that's when there's a big possibility that 1, they're going to lose their productivity, 2, they're going to create bugs. And that's what we don't want them to do. So we want that time to be as short as possible. And the next thing that I want to highlight is this manual testing. And again, this is where, at least when we'd started to transition from my previous companies from waterfall to agile, this was a huge change in the way that we worked, right? So going from 3 months to a day, or maybe 2 to 3 days, is a big, big difference. And it makes the testing job harder. So of course, like I was saying, this doesn't seem to work very often, at least in the companies that I've seen in New Zealand. It's sort of what everyone strives for. And so when I started Appsurify, it was really to try to mimic what the really impressive companies like Google and Facebook were doing, because I knew that they have thousands of tests, they're running them regularly, and they're getting results to the developers quickly. So how are they releasing software at this level of speed? But a lot of the companies that I'm seeing can't. So just to quickly go through this, what does a day look like when you've got these problems with your CI? Why do we need to fix these problems? So Dev 1 comes in at 9 a.m. He does his commit. He runs the build. The build obviously takes longer than what we'd hoped. The unit tests run, and then the API tests, they take 10 minutes to run, right? There's 1,000 failures, and James is super confused. So he spends 10 minutes investigating. So you can see already we're losing a lot of time compared to that 3 minutes that I was hoping for. He finds a fix. It's actually a network problem, or maybe a problem on the box that they're running the API tests on. He's like, the easiest thing to do is just rerun the test. I don't have time to investigate further. So he's ready at 10:30 to give this another shot. At 10:30, he recommits. He's got the build, it runs. He decides, okay, I know that this is going to take a while. I'm going to go get coffee. So the unit tests run, and then the API tests run. And like I said, he's set the API tests to run multiple times so that he can get that green signal that everyone hopes for. They all run and they pass, thankfully. Maybe it takes a couple of runs. But then the next problem is the UI tests. They are now taking 2 hours to run, and there's 100 failures. So you can imagine he's come back from his coffee break, he's moved on to the next task, he's jumping into this piece of code, he has no idea how to write PHP, so he's super confused, he's just in the middle of making a change, and then suddenly he's got a context switch and look through a whole bunch of XML to try to find out, okay, what has gone wrong with these UI tests? And this is tough. Like there's a huge amount of data in this, and a lot of those tests are probably all failing because of one bug that he's created, or maybe someone else has created. And so he's spending a lot of time just doing this investigation. So I put him down for 40 minutes investigating. He's got 100 failures to look at, right? So looking just through that and then retesting them takes him a good 40 minutes to try to understand the problem. So there's an actual bug. So this is obviously an unrealistic scenario because I've never made a bug in my life. But he creates a fix. And so it's now 4:30. He's spent his entire day trying to do this one commit. He does the commit again with the fix. The build picks it up. He goes for his next coffee. Maybe he goes to play table tennis instead. He runs some unit tests. Then the API tests run again. And of course, what he's done and what I see a lot of, because the UI tests take a long time to run, he ends up removing them. We can't have the UI tests as part of a gated check-in where we're trying to get fast feedback if they're taking longer than 5 minutes. So he removes them. He's like, I cannot wait for this. I want to go home. So after the API test run and pass, he just does a deploy. And of course, that takes longer than expected. It always does. But the thing that is next is the manual testers, right? It was 4:30 when this started, so it's over 5:30 now. It's probably closer to 6. And the poor manual testers, they know that this is a critical change. So they've stayed waiting for this commit to come through, so that then they can do their manual testing, sign off, and then get this pushed out because it's a critical change. And of course, the problem is that they miss a bug. They expected the UI tests to be run. They expected the results, to have found the bug. So they've actually done testing in a different area, and they've missed a bug that would have been caught by these UI tests. And so at 2 a.m., a poor user finds the bug, and then it alerts the team. And so you can imagine this is where the QA gets blamed. And this is what used to frustrate me the most, where, again, it needs to be a team responsibility. But instead, quite often what happens is QA are blamed. How did you miss that defect? But the thing is, this type of failure is not just frustrating the QA, the developers hate it as well. This is the type of thing that will make a developer leave a company. They do not like these flaky or slow CI/CD pipelines. You can imagine his day. He started at 9. He had a whole bunch of stuff that he had to do. He knew there were deadlines, and he spent an entire day just trying to get this one commit in. That's not an enjoyable place for him to be working at. So if we, I guess, highlight the challenges that we've seen here, and I guess if we can fix these, this will help us shift left and help us improve the day-to-day of both the testers and the developers. So the first thing to highlight is, again, the test took too long to run. If they're taking longer than that, 3 to 5 minutes, it's frustrating to the developers, and it's leading to this potential context switching. And the next thing, the tests are unreliable. If you don't have reliable tests that are giving you that green signal when it is a green build, if you've got these things called flaky tests and suddenly, a test fails, but it's not a real failure, and your developers are spending time investigating that, then that's the type of thing that is going to prevent you having those tests as part of the CI and prevent you shifting left. And then, of course, the final challenge is that there's not enough time to test. The manual testers themselves, they've been squeezed. They are now essentially relying, and like the previous talk talked about this, they're relying on their own bias to try to work out where they should be testing. They've got this history of knowing, okay, usually this happens, now I should probably test this, but they're limited in what they've seen, and they're limited in their full understanding of what the developers have actually done. So quite often we don't have enough time to test, and we might miss bugs. So with automation, let's go through how we can solve this problem with a lot of automation. Because what I've seen happen, right, is you have new management come in, and everything looks like it's going to be amazing. They've decided to automate everything, which is probably actually a good thing, but there's this, like we talked about, there's suddenly a traffic jam and you've got too much automation, or you can't handle running that in the time frame that's available. So what can we do instead? Once it becomes this, you've got a lot of automation, they take a long time to run. What companies start to do is they start to say, okay, maybe we should split these tests into different groups. Maybe we should run a subset first, and then we'll run a larger set overnight. Or maybe we won't run those tests and we'll just leave those to the manual testers. Of course, this makes shifting left harder. It makes it more likely that you're going to miss a bug, because you're essentially guessing which tests are useful, rather than saying, okay, for this change, this is the useful set of tests. And that's going to lead to, your developers context switching. They're going to get information late. All the things that we wanted to try to avoid, it's essentially just delaying them. It is getting some faster feedback, so it's better than having no tests run at all, but it's not ideal. So what I've seen, and there are a couple of papers on this, and this is actually what we do as a company at Appsurify, is instead of running all the tests, how can we prioritize which tests get run? Let me just check chat. Okay, that hasn't popped up at all, so I have to check it at the end. So yeah, this is what Google and Facebook are doing, where instead of just running all of the tests, instead of just having this smaller smoke test run, they are instead running a much smaller set of tests just based on the change that the developers have done. And you can say, okay, so how can we work out which tests to run? And that's where we've got all this data, just like the previous talk was talking about. We have all this data about which tests have failed and which change has made those tests to fail. That's all in our data stores. We know what commits have come through, we know what files they've changed, and then we know the results of the tests. That's all our history. And when we're trying to work out which tests to run, that's where testing is a little bit different than everything else. We are trying to get a failure. Running a passing test, if we're trying to get down to that 3-minute nirvana, that's where we only really want to run the tests that are likely to fail. So, I mean, the last talk is actually super useful because it helped. I don't need to go into a classification algorithm now because that's what we're trying to do. We're trying to classify, is a test going to pass or is a test going to fail? And then we are just going to run the test that we've classified as going to fail. So from that, we can obviously cut the testing down significantly. We've found that, well, Google found that they cut their testing down from, I think, they're already doing some things to cut down their testing, but we've cut our testing down 90% plus on what we were originally running through test automation. So the next challenge is that although we've got faster automation, we've still got a whole bunch of tests that are essentially unreliable, this idea of flaky tests. And Google says their tests fail, essentially 74% of their test failures are caused by flaky tests. And I'll speed up because I know we've got a little bit low on time. The next quote is just from John Miko, who was, I guess, one of the lead testers at Google, where he said almost 16% of our tests have some level of flakiness associated with them. And if you think this is Google, they should know what they're doing. These are world-class developers and they're still having this problem. Of like solving this is rerun the tests or delete the tests. Rerunning sounds great in theory, but potentially it's going to give you that same headache that you had before where you're suddenly running too many tests. And this is again where we can have a classification model that can say, okay, is this failure a good failure? Or is it a failure because the dev has done a change that we expect to fail? Or is it a failure that's just caused by flakiness? And then we can quarantine, or we can actually look at the results and handle them in a different way depending on what we think that failure is. And then we can highlight that to the test team to be like, maybe this is what you should investigate. And I know all of this sounds a little bit complex, but it's actually not. It's essentially what good testers would do if they could consume all this data and make these decisions themselves. So the model we use for when we're trying to determine is a failure flaky is really based on what I would do as a tester. So if you're looking, I apologize, I just for failures. So if you are looking at trying to determine if a failure is flaky, if a test fails early on, we know as testers that that quite often is doing data setup. It's not actually at the testing part. So we know early failures more likely to be flaky. So our model reflects that. That's what the model looks for as well. We also know that there are common failure reasons. Like this is, a very standard failure where there's a WebDriver exception trying to create the remote WebDriver. And this used to happen to me all the time when I was doing test automation. This is a common failure that we know is not the test failing. It's sort of like the infrastructure failing instead. And again, we've got errors versus cert failures. Obviously, the model is taking that into account as well, where an error is more likely to be flaky, whereas an assert is more likely to be a real bug. And then the history of the test itself, that can also determine whether it's going to be flaky. So by doing this, we can really have that fast and useful automation that can give the reliable signal to the developers and stop them being frustrated. But this isn't helping with the manual side. So what can we do to essentially make our testers like superheroes? How can we reduce the burden of the testing so that they can test smarter? They're not working those late hours, and we can get results faster, find the bugs faster, just like Philip was talking about. So again, this is where we've got the history. We've got this giant defect history that we've got in Jira or whatever tool you're using, where we know what has caused defects in the past. We know which developer has created those bugs. We even know which commits have created those bugs. And so we can make a similar classification model where we can classify a change as being risky or not. Like, how likely is this change to have actually created a defect? And so again, this is what we're analyzing. We've got all of this data. And so the first thing, this is again what a good tester would, I guess, look for if they were looking into the commit data and the bug history. They're looking at how experienced is the developer that's making the change? How experienced are they with the area, with the task type? Have they created bugs in this area before? So someone that is more experienced, that's created fewer bugs, is obviously less likely to create a bug in a new task. Whereas someone that hasn't picked up this type of task before, someone that usually creates bugs in this area, they are more likely to create a bug when they do a change in their area, right? It's pretty much common sense. And that's what the machine learning is just really good at, consuming all that data to make this type of selection for you. And then again, this may be a little bit more interesting, that maybe something that you haven't thought of, where if you've got a developer and he's making a change in the code and he's by himself, he's less likely to make a change than if you've got 10 developers all changing a similar area in the code together. They're essentially likely to trip over each other, which is what I was trying to show in that video. You know, one guy changes a method, another guy expects, or another girl expects that method to work the way that they previously saw it. So they're more likely to trip over each other. And then this image is a little bit weird, but what I'm trying to say is a small change or a set of small changes is far less scary than one really big change. A bigger change is more likely to be risky, and that's what the model looks at as well. And this is my favorite slide, so I'm glad I've got to it in time. Often the developers are even telling us where they're creating bugs, and the testers aren't looking, whereas a machine learning model that is collecting all this data, it's doing that automatically. So you'll see things like, you know, I've written things like, don't change this. I'm pretty sure this works, all in the commit messages. I like this one as well, like, I'm sorry, someone is not going to enjoy refactoring this, or someone might even put in their commit, like, to do refactor, and then you know that it's a complex piece of code that needs to be looked at. And then finally, again, like, fuck JavaScript. Maybe I shouldn't have said that given this is being recorded, but I think that sums up a lot of people. And if someone is just smashing their keyboard and then putting in a commit message, it's indicating that this is probably something that they didn't enjoy doing, probably something where they struggled, and you know, our model can pick that type of detail up and then tell you this is a risky change. And then, you know, it's early in the morning for me. I'm not usually, well, I go up at 6. I'm not usually up that early. If I'm up that early and I make a change, a tester would know that they need to test it. If someone's just had a newborn baby and they're not getting any sleep, you know that you need to test their code more thoroughly. For someone that's well rested. And that's the type of thing where we can actually start to see patterns for the developers, just like Philip was saying. We can even see patterns based on when agile ceremonies are taking place. When someone is about to, let's say, finish the sprint, they're more likely to rush to check in code, which is more likely to essentially cause a bug. So a machine learning model can pick all of this type of data up, and that's what we're essentially helping teams with, so that they can really fast track their testing. And so by doing this just in time, we can sort of help reduce the testing scope while still finding all of those bugs, just like Philip was saying. And in terms of the results, we're reducing the testing by, especially the automation testing, by 90% plus, and really helping companies target that manual testing. So yeah, just helping them, I guess, build in what the Googles and Facebooks are doing because they've got these large teams. So yeah, that's it. Thanks for listening. I will hand it back to Andrew, or he can take control.
Just one thing. Thanks for that, James. I think Michael Bolton was raising one question around the definition of, I think, of flaky tests.
Yeah.
So he was. Let's have a look. What was he saying? So could you please be clear on what this means? Flaky tests precisely means bugs in the test code. So I think that is what he's trying to get across to you on the chat when you were a bit earlier.
Yeah, sorry. I'm only on my laptop because I'm in quarantine. I don't have my usual setup, so I couldn't see chat. But so a flaky test can be. The problem is we've defined it as a flaky test, and oftentimes it could be a badly written test, but it could be an issue with a whole bunch of other things. It could be a race condition in the application, and then you might say, okay, well that's a bug. But it could be something that we're mitigating in another way so that the users will never see it. Or it could be an issue with the environment. And again, we're mitigating that in production. So it's something that the test is failing because of, but we don't actually need to fix it because a user will never see that problem. So it's really showing you that there's some instability. It could be, but essentially the test is non-deterministic. And quite often, people will say, my tests will pass, 99% of the time, but that's not high enough. If you've got a 99% pass rate and it's causing, and all of your tests, let's say you've got 1,000 tests and they all fail 1% of the time, that's going to cause your build to break really frequently. So we've got to find a way to either remove that flakiness, which sometimes isn't possible, like I've just talked about. In fact, I had a friend at Google where they had 10,000 tests that were failing because of this network condition. He's part of their SRE team. And to fix that was going to take him hours, if not months. And it's something that no one in production was seeing because the infrastructure essentially handles the problem. He's never going to fix that issue. So those tests are always going to be flaky. But thankfully, Google's system will determine if the test is flaky and then pass the build anyway. And that's what we're trying to do instead. Okay. And so I'm not so sure if I've answered that question well enough, but I'm happy. I'll jump into chat now.
I know Michael will tell us anyway if we're not.
Yeah.
So, okay, so that's great. So can we now pass over? That's great presentation. Thanks very much, James. The final presentation, Mr. Ian Sharp from Slalom. Over to you.
Great, thank you. Andrew, are we still on a hard drop for 8 o'clock or?
No, we can run over a little bit, I think. We've still got a lot of people on the call, so I think everybody's enjoying it. So, yeah, over to you.
Good stuff, thank you. Okay, first of all, thank you, Andrew and the wider team for making this happen under the current challenges. I think AI in testing ages might have been a bit more opposite, but it's great that we've all sort of come together today. So a little bit about me before I go through the shape of what we're going to cover this evening. I'm 2 months into a new role at Slalom. So I joined Slalom a couple of months ago in simpler, more innocent times, it seems, as head of Responsible AI. Prior to that, I've spent 20 years at Oracle and Microsoft, so purely on the enterprise side of the business. So at Oracle, I was head of AI design and innovation for key accounts across the EMEA JPAC, so covering all those areas. And I worked in Microsoft in the comms and media pod. And prior to that, I was a data scientist. So I headed up data science for Oracle UK Azure Online. And so I've spent a whole bunch of time in this space. And really, what I wanted to do today was just cover something off from a more practical use case perspective in light of the main challenges that I see from getting AI workloads tested and into a development operation. And these are from there may well be more but these are from my personal experiences in the past 5 years working for the two largest enterprise technology companies in the world in a field role. So hopefully there'll be value in that. And I think, you know, the key thing is, you know, what are the sort of challenges we're seeing and how people are getting around this, and then maybe wrap up with some ideas around some practical advice, some suggestions about what we could practically do, and get involved in that. I have to say, when I first saw the title around making AI relevant, it was a bit spiky, bordering on rude, but actually this is very much about, and I think hopefully these use cases will evidence that fairly clearly, that if test and DevOps are not involved in the cycle of development around AI, then very often those projects will fail. And I'll hopefully give some practical examples as to why that happens. So it's not just a case of a hand up to our community, it's that you are absolutely the lifeblood of whether these things live or die. So I'm going to talk about probably about 3 or 4 practical case studies that I've seen that hopefully evidence and maybe give you some ammunition. But before I do, I'm conscious of the fact that we're probably working with a fairly diverse audience. So just to give a bit of context in terms of what we kind of mean by AI and what the landscape looks like right now in 2020. I think it's kind of ironic looking at this. It covers The Economist, which was, I think, in January of this year, where it highlighted what the world was going to look like in 2020. And I hope you can look at this. It's Trump, Brexit, AI, Tokyo, climate change. I'm looking to see if there's any sort of tiny print down at the bottom in terms of virus. I'm not sure if there is, but regardless, you know, if and when the world returns to the new normal, we know that we will be dealing with these things, so they will become relevant again in this context. And again, you know, in terms of the definitions of what we talk about AI, I know we've spent a huge amount of time here. I'd probably keep this fairly high level, but just so we're all on the same sort of playing field. This is the definition I've used for the MOD, and really taken from The Guardian, which is a broadsheet, a well-respected broadsheet in the UK. And generally characterises AI as at a high level, either narrow or a weak AI, and general or wider AI. And I think we split this into 2 sort of main bags. I'm sure many of you, and going back to some of the books that Andrew called out earlier on, will be aware of the concept of sentient machines and artificial generalized intelligence. It's kind of my hand on heart from a commercial implementation point of view. I probably worked with over 300 customers in the last 5 years. I found maybe 1 commercial use case of this. So this is kind of like future state stuff. The area that we're really operating in is in the space of the narrow stream of AI. So robotics, chatbots, that sort of stuff, and then the whole world of algorithms. I'm not going to bore you with all the details of the different derivatives, and I think Philip gave a very clear and good introduction to the whole concept earlier on. But so I say they're ever evolving, and some of the algorithms that we use have a major impact in terms of what we're doing. I'm going to be coming back to that later on. You know, good and bad use cases. There's some scary stuff on the left, but there's also a whole bunch of good stuff coming out. So I think this is taken a little image of the chimney. I think it was taken from Salesforce for good AI operations in Honduras around creating intelligent stoves. And again, we're sort of seeing in the outbreak of the coronavirus. You know, I probably had about half a dozen conversations with very different people in government and the NHS, and just the world network in terms of getting people who care and people who maybe have some ideas, and sort of taking egos out of the room and trying to work on these problems. So I think what we'll see, and this is the essence of what really today is all about, is becoming much more involved and collaborative in the whole process, because you need it. So that's the kind of context to it. And then the bottom left-hand side, one of the challenges I think we have with AI, and when it comes to the testing phase, you will fall victim to this, is the hype curve. So very often, so finally the business actually cares about what we're doing. They never really cared about DevOps. They never cared about statistics or databases or any of that sort of stuff. And this is a mixed blessing. So it's a blessing and a curse at the same time. So it's great that they care. The challenge is they're often drawn to the extreme edge cases. And so people often ask me, what's the edge case? What's the coolest kind of AI stuff at the moment? And to answer that, it's probably commercially things like contextual AI. So in a previous life, we handled YouTube's contextual AI for brand safety in terms of sort of surfing through their web pages to see if they were safe in those ways. But the reality is that those kind of edge cases are generally handled by agencies. So I imagine if you're like me, you're probably working with large commercial organizations and governments. That's the mainstay of how we earn our livings these days. And most of those edge cases around that are probably 5 to 10 years out, arguably. The other challenge that we find is that a lot of the flashy use cases that grab attention, things like spotting walruses on beaches and counting fish in an aquarium, et cetera, and we've seen a whole bunch of these in the evolution, tend to grab the attention, but what we find is that the business cases for implementing them tend to be quite weak. And then, we tend to look at sort of geeky stuff like SHA-2 encryption, which takes 118 million years to hack, I'm reliably told. But then again, the businesses doesn't really be able to afford or implement these sort of things. And that's the nub of it. The point is that right now, I think there's consensus around the potential and value of AI. If we look at these three numbers in the center, they kind of bear it out. So McKinsey's estimate the market value of AI is about 13 trillion in the next 10 years. And we probably wouldn't argue that too hard. But the really interesting thing here, a number for me here, is the 83% of corporate assets are intangible, which is clearly a bad thing. And a considerable chunk of that is data. And so what we're seeing here in this space is that a lot of organizations recognize the value of AI and data and not being able to surface this properly. And when we drill into it, if we look at the conversations I have, most of those reasons are not to do with advanced AI or data scientists or access to tools. They're to do with more mundane practicalities of getting things into an operation securely. So, going beyond the simple Dockerized Kubernetes API and JSON workloads, which practically doesn't really cut it for enterprise grade applications, or getting data into the systems in the first place. So in summary, what we see is this sort of huge trade-off in between the hype around AI and the difficulties. And most of the challenges that I see are generally based around the fact that we can't operate these in a production environment. And I'm going to highlight some of the reasons as to why we see that to be a fact. So if we take it up a level, we look at a vanilla pipeline of an AI solution from ingestion into the central part, which is the wrangling, the exploratory data analysis, the building the models themselves and evaluating. And that's really pretty well served with technologies and tools. So generally speaking, a lot of developers will be using, data scientists will be using things like Jupyter or notebooks. And I saw the love on the previous presentation from James about Jupyter. We feel the same way about DevOps as well. I think we've said similar things, or other concepts around libraries like we're seeing an emergence of things like Zeppelin as a framework for doing that. And then in terms of being able to get them into a production environment, there's a whole bunch of tools. So AWS SageMaker is pretty strong. Domino, Oracle have technologies to do this. Data Science Workbench, H2O, Domino, et cetera, et cetera. So there's a whole bunch of technologies that allow us to take place to manage the middle part. The part that it gets really difficult for us is in actually operating into a production environment. And that's really what I'm going to focus on today and highlight some of those challenges. So as an example, I'm going to call out a couple of these. These are all public domain. So this is from a previous slide. So this is an organization called the Perform Group, the world's biggest sports media company. So in the US, they're best known for the baseball, for the football and the basketball franchises. In Europe and the rest of the world, they're probably best known for things like soccer. And their customers include the tier one broadcasters, the likes of Sky, ESPN, BT, those kind of organizations, the broadsheet newspapers, and the clubs themselves, of course, because the clubs are becoming much more statistical. And they're a fascinating organization because they live and breathe data. And they have two primary feeds of data. They have a relational feed, which is basically a whole bunch of kids sitting around with Xbox controllers near the Shard, watching every single football match, which would have been my son's dream job a couple of years ago. And they record that kind of data, and it's everything from small events like throw-ins or fouls or foul throws, right through to goals themselves. And it's a relational data feed. Now, they have a second feed, which is 25 frame per second cameras, high definition cameras around La Liga and Premiership matches. So it's an IoT type data set. And to merge these two streams of data in real time in a match is worth a fortune to them. So everybody, all the broadcasters, all the teams, all the clubs, all want to know what's happening in real time around these two feeds of data. but it's really hard. It's really complicated because all you've got with a with the camera definition is an XY coordinate of where the ball is, an XY coordinate of where the player is, and an XYZ coordinate of where the ball is. So when this amazing guy here, Messi, I don't know if you all know him. I presented this in the past in real meetups, and I can see people nodding. I'm presuming pretty much everybody knows him. So when this extraordinary footballer Messi does something called a nutmeg, then technically for a point in time, that ball is closer to somebody else. And that's actually quite hard to model from an analytical point of view. So cut a long story short, we managed to work with them and help them fix this particular problem with a combination of machine learning. So cameras are a nightmare. On corners, all the players are piling into a small area in real time very, very quickly. So it's hard to differentiate between those players. Cameras fail. Players with bibs running up and down the side of the pitches. Pitches are different sides, so it's hard to tell what's going on there. So there's a whole scope for error. And obviously, if this organization starts to spew erroneous data in real time to the likes of Sky, then the whole brand equity, which is built around data quality, is destroyed. So high risk, high reward in terms of how this works. And we fix the problem for them with generally speaking compute, to the extent that what they can now do is they can recalibrate the odds of a goal being scored in real time based on the geospatial position of a player in the box when a corner is being taken. And they use a library called Scala to do this. And this is kind of really interesting because when we look at the different libraries available to us from a statistical point of view, then generally speaking, you'll have things like R, which are extremely programmatically rich and statistically rich. There's a huge range of algorithms that will do this sort of thing, through to Python frameworks like scikit, Spark, and into Scala. Now the trade-off here is that actually when you look at running R algorithms on large nodes, then they're notoriously spotty in terms of dropping objects between the connections. So they become extremely unreliable in terms of running these things. So they had to retrain all their data scientists to to actually run a far more robust framework for making this operate in real time which is called Scala. The trade-off with Scala is you have fewer algorithms, and so generally speaking, organizations maybe gravitate towards a central place like Python, where you've got maybe not as much choice or low-grade control over the deep learning and AI models themselves, as you would do with R, but you have more control and you know, it's far more robust in terms of inter-node performance. So so we've seen a whole bunch of stuff around this, and you know, a classic example will be something like market attribution. So in market attribution, which is what lots of direct market agencies use to measure engagement, the most common algorithm they use is something called a prop hazards, which is heavily statistical. The stats people love it, but it's only available in R. So you'll only use things like Cox proportional hazards or Kaplan-Meier to do that. They'll probably never have anything in Python. There's certainly been nothing so far. And so what we'll see is that, you know, as your data scientists are building this, they will have no visibility at all of what the performance implications will be like. Their offload to any of this is a REST API point with a bunch of JSON payloads. But as system engineers, you know what the operational performance is going to be like, and I think the performance case is a classic example of this. So from a DevOps point of view, it's really important to be involved in that conversation early on and make the data scientists aware of the performance issues around this, because I've seen any number of projects being killed off where a great data science experiment, which is giving superb results, simply can't run because it's not robust enough to perform in an operation. You know, the chosen libraries won't scale, or they're not reliable enough to meet the operational needs. So, so my advice in this one is just get involved early on in that pipelining experience and make sure that the project sponsors hear your voice, if you like, because it's absolutely critical. One sort of quick point, actually, quite funny. If you follow football, the clubs are getting extremely statistical in this whole thing. So they talk about the golden triangle, which is or the golden third, which is the final third of the pitch. And they look at the passing angle between the attacking midfielder and the two forwards ahead of them. And they look at the angle between those passes. and they found there's a guy called David Silva who plays for Man City, who seems to be some sort of genius at Euclidean geometry because his angles are better than anybody else. So so it's just an example of how statsy people are getting. But yeah, from a real performance point of view, this is absolutely key to get involved in those things. And just sort of moving on from this, I'm conscious I'm talking reasonably quickly here, but I'd rather get through the material than miss stuff out. And that really brings us up to this really big challenge that we have, which is actually in making performance critical AI deployments work. So here's a bunch of stuff. Now, how much of you have looked at things like TensorFlows? So generally speaking, the most basic way that we get Dockerized Kubernetes workloads working out on JSON, on UJSON things is through the standard kind of frameworks that I described earlier on. But actually, when we look at the performance here, so this is looking at some sort of benchmarks we ran, and we can start to optimize them a little bit with things like protocol buffers. So I don't know how many. So most organizations I talk to at the moment tend to use TensorFlow. It's the dominant, and Keras, it's the dominant library out there. But you know, the challenge is that when we run sort of serialization and deserialization requests on floating tensor data using an API, you know, it just doesn't cut it from an enterprise performance. It's just not going to be performance critical enough to this. So this is really showcasing this. There's a cool bit of open source stuff I'd point you towards called GraphPipe that really sort of seeks to address some of this sort of stuff. You just think of it as like a protocol for flat buffers, but with a whole bunch of other cool stuff built into it. But you know, effectively what this is doing is it's sort of comparing those points. I think this is running something called a long short-term an LSTM, or a long short-term neural network, and I'll come on to, or activation function to a neural net, which I'll come on to in a minute. I think the request here was looking at about 19 million floating points and it was on image data, so you know, it was 128 by 224 by 3 images. And then, so, you know, we look at the units here and we can see this sort of massive improvement in terms of these things. So just, you know, if people are just going to hand you an API, then just, you know, look around, see if you can optimize some of these stuff. Some of the documentation of this is kind of weak as well in terms of, you know, if you've ever tried to get the protocol buffers optimized in TensorFlow, you're going to spend days banging your head against the wall. So check out some of these open source things around GraphPipe that can really help. But it sort of illustrates the sort of challenge that we face in terms of things that our data scientists wouldn't necessarily even care about. And I mentioned something called LSTMs, long short-term neural networks. And the second big challenge that you're going to find as a development team and a testing team really comes from the likes of Netflix, so the saviors of all our worlds at the moment. But one of the challenges is that Netflix runs something called a Netflix prize, where they basically offer $1 million to any data scientist or anybody who can come up with a better recommendation engine they've currently got. So not surprisingly, every single data scientist seems to go after this. And over the past few years, it's always been won by something called an ensemble model. Basically, what this means is it's a way, it's a deep learning algorithm that creates lots of smaller models rather than one big overall model that's going to predict more subtly. So it's going to break the problem down into smaller gradients. The challenge with this is that pretty much every organization I seem to be coming across, their data scientists are fixated on running these ensemble models. And I'll come back to why that's so difficult later on, because very often you've got the problems of different frameworks. So you may be using Keras for one, or Caffe2, or DL4J for another, and there's no common way to manage the client implementation for Go, Python, and Tensors, as well as the server side of things as well. So just be aware of this. And just as an example, so just look at some of the evidence around this. So just quick 101 around deep learning. So on the top left-hand side, this is a fairly generic deep learning algorithm here. It's probably a CNN or something like that. And running against this is, so what you've got going on is you've got a whole series of input nodes, then you've got a series of calculations it makes in the middle, and then it outputs that value into what's called a softmax which is basically a logit scoring mechanism. So it's just an ungraded a way of holding our data. We then apply some sort of cross entropy function to recode that as a probability, and then finally we use a one-hot encoder to put it into the categorization of the model itself. So if it's binary or multi-class, so there's a whole bunch of processing going on there. Then we tend to use these things called long short-term nets. The reason we do that is because as a data scientist, the problem we have is when we have these complicated neural networks which are feeding backwards and forwards, what we're trying to do is get it to train, and we use something called a stochastic gradient descent. And the idea behind this is it's going to fit its values to minimize loss. So when we're using things like feed forward and back propagation nets, what happens is as we're feeding back, we get a whole set of correlated updates of what's called weighted derivative weights. And that is bad news for what's called SDG. So the maths becomes really, really unstable. And what this leads to is what's called either exploding or vanishing gradients where nothing trains, which is our nightmare scenario. So these LSTMs were introduced to try and get around that. So they had some sort of gated functions in there that have memory. Now, within each of these processing units, you have a whole series of what's called logistic regression models, which is pretty CPU intensive in itself because it involves lots of recursive table vector scanning, and then the output of that is you will have something called a hyperbolic tangent that recodes it. So the point of all this massive spiel that I've gone into is that there is a huge, ridiculous amount of processing going on in these models themselves that has to come from somewhere. So the smarter the models get, the quicker they get, the harder it becomes to process. And going back to the Netflix story, I was told reliably from somebody very close to the organization that none of the ensembles that won the prize have ever been implemented because the predictive gain it gives over and above what I presume they're using at the moment, which is probably some collaborative filtering or some more basic statistical naive Bayes, is so tiny. I think it's about 0.87, that it just wasn't worth the investment in the additional CPU and processing and architecture to do so. So hey, this is sort of key point in terms of how we make this whole thing work. And it gets really, really, really complicated. The other problem with this is that when you've got people using different libraries with different sort of standards, so you may be using TensorFlow for one of them, or you may be using Caffe2 for another, there is no common model serving technique across that estate. So these smart guys at GraphPipe have looked at that, and they've created an environment that allows you to do that. So it serves up some of those common things and gets around it. But just to be aware, this is the sort of problem that you will be dealing with, or you may well be dealing with in the commercial world. So take a look at this sort of stuff, because it can handle pretty much anything written in MX, MXNet, CNTK, Caffe, PyTorch, Tensor, all those kind of libraries. Finally, the other thing I kind of wanted to say at this stage is, if only still there, one thing I've noticed is the AI is getting scarily good, and maybe this is obvious to you, but back 3 years ago at Microsoft, we were struggling to tell the difference between cats and dogs accurately with AI. Now they're getting to the stage where they can classify outcomes probably better than we can, and it's largely down to increased amounts of data. It's down to the explosion in GPU. So going back to the contextual AI that I showed earlier, which is sometimes run on what's called, I guess, grime music to look for patterns of maybe criminal behavior in there. As an old man, I find that sort of music very hard to understand. I find it very hard to extract the meaning from what they're saying, which is probably quite intentional. My son, being a privately educated schoolboy from Bath, finds it immensely interesting. What we found about 6 months ago is that the AI has actually overtaken the abilities of even humans and the youngest experts to understand what's going on in this whole context. And this is a sort of case study that we did recently, which is kind of funky, is around honey fraud. Honey fraud is the third most fraudulently contaminated food product in the world after, I think, olive oil and milk. And the way it works at the moment is that a field expert goes into the field. He takes a microscopic image of honey, he takes it back to a lab, and then an expert puts it underneath a microscope, and this expert can tell the difference between every different type of pollen from apple to whatever else. So if a pure British honey suddenly has eucalyptus or mango appearing in it, or apple at the wrong time of the year, then we know it's fraud. Now, this is a manually intensive process. We ran this through some AI. So I built a pretty simple VG60 Inception Net v3. So it's a CNN thing, hacked a couple of functions here. So I don't know if you can see the code at the bottom left-hand corner. And what we can now do is we can take that into the field, stick it on, stick a microscope on the end of an iPhone or any other phone, take a photograph, and in real time, it'll figure out what the probability of what that pollen sample is as good, if not better, than a human being can. So it's scarily good. What was actually really impressive as well is it was on a tiny data set, so we didn't even use things like GANs to make that optimized and work properly. But the challenge we face from a business point of view, certainly in GDPR countries, is with that data. So if we're running things on a phone itself, then how are we ever going to basically, get that stuff deployed back? Because we can't write any of that data back to the server, right? Because it's private data. So there's some evolutions around. So take a look at some of the things around TensorFlow Lite. That's pretty cool. So what that means is that we can actually run the whole model and deploy it all on the phone itself. It's pretty cool. There's a slight degrading in accuracy, I think by about 1.1%, but it runs 4 times quicker. The latency we saw on this one was down from, I think, about 1200 milliseconds to about 900. So there are ways around, how we can start to do sort of some of the cooler stuff without writing back to a server itself. There's a whole bunch of stuff that we can sort of see in this space, guys. I'm really conscious. I'm going to wrap up now because I'm conscious of the time. Hopefully, I've kept to my half hour or so. One final thing, though, and I think this is really important, the ethical side of things. So in previous life, I worked at Oracle. We were looking at an opportunity, a challenge in Manchester, where in Manchester, they spend about $250 million a year amputating feet of type 2 diabetes sufferers. So, and which is a shocking number and just a dreadful state of affairs. So some really smart people from a Metropolitan University have developed some algorithms that with a very high probability can take a photograph from a standardized distance away from that foot. And so basically if a person takes a photograph of a sore on their ankle, it can profile whether that's something that is just a sore or it's something they've got to do something about very, very quickly. But the challenge remains, although the algorithms are very, very smart and maybe more smarter and reliable than the human, what happens when we get it wrong, the false negative scenario, and how do we as people forgive AI from getting it wrong as much as the algorithms themselves. Now, the reason that's important to DevOps is because once all your data scientists are going to develop is a score. It's a probability and association. But in terms of the person-on intervention into that, that'll be kind of up to you guys to sort of be thinking about, how can we write code to maybe sort of apply some interception rules around that. So yeah, it's an ethical implementation, but you guys are going to be on the tip. And actually, all these ethical implementations are all shared around this. So I'm just going to wrap up here in terms of just think that we've crystallized. My big thing coming from Oracle, when I look at the successes, and this is heresy for me coming from a software company, is the reality is that most of the fixes are not to do with software. The software is always out there, and most organizations have enough software to solve most problems. Most of it is about not actually connecting people and connecting the business, connecting IT, connecting DevOps, and connecting data science. And so we have this sort of thing called modern data culture, which is an experience where we bring all these groups together. And you guys are absolutely central to the whole part of that conversation, because without you guys being involved, it really doesn't work. And we did a recent event with AWS, Snowflake, Tableau called Moonshot, which is all about the Apollo moonshot. And I think this is a great quote taken from there, which said that, actually what it really was less about engineering and technology and more about people working together and developing the right culture. So so I'm going to wrap up there, but before I sign off, I'm going to leave you with the coolest bit of AI in the world right now, because I think everybody's waiting for this. And this is kind of it, right, guys? I thought you'd be impressed with this, particularly the sort of second bottom line, because this is an example, and actually this is a DevOps thing. So this is taken again from GraphPipe. So this is a way that we can remotely serve those ensemble models at speed and optimizing flat buffers. And a data scientist isn't going to know any of this, but unless you guys are involved to save the day, then I think we're all doomed. So guys, thank you for listening. Hopefully that was useful. I'm going to hand back to Andrew now.
Thank you very much, Ian. That was a good presentation. Thank you again. So one of the things I think that there's been some general chat on the discussion, and what I want to do is just finish off with a few points. It's like Michael sharing some stuff here on the chat. So I think some of the discussion was about, and this was directed to all three speakers, was about how you test, approaches to testing AI-based systems. So maybe, I don't know if Philip, you could kick off the Q&A with that. Maybe that'd be a useful start.
Yeah, sure. I mean, I think just from the crux of my talk was about the data and the issues with the data, and also the way that the AI learns from the data and processes it. So it's really about testing whether or not the AI is learning correctly and examining the data correctly. So it's really about, as I said in the chat window, is it's about understanding those algorithms and whether or not they're learning correctly and whether or not they have biases, correcting those biases as well. So that applies to all AI systems, whether or not it's testing or anything else that Ian was talking about.
Okay. Does that help on I think because I think people were talking about more practical activities. So I don't know, James, if you can build on that conversation that Philip just shared on that answer. From you.
Sure. No, I mean, what we've been doing to test our AI is really, I mean, what Philip's saying is what we're doing. How can we create data sets that essentially mimic what we would expect to see, and then make sure that we're getting the correct recommendation? So your test cases almost instead become like data sets, whether they're big or small, and then you try to think of essentially what data could be in that data set that might cause the model to create a prediction that you wouldn't be happy with. So your job almost becomes, how can, what data scenarios can I come up with that might essentially trick the model into doing something that we wouldn't expect it to? I mean, I think it was Philip that had the gorilla example, because there are a number of examples like that where machine learning models have created an incorrect, they've had an incorrect result. And a lot of that is just because they didn't come up with the data scenarios to test that. But I'm guessing that Ian will be able to go into further depth on it, or may be able to.
Yeah, no, sure. I think that's a good comment. The other thing is, if you look at the end-to-end pipeline, most of the models tend to, as long as you're choosing the right one, there tends not to be a huge difference between the performance. It tends to be the ingress of the structure of data that really affects it. You generally speaking get some, and also data quality itself. I know it sounds trite, but as the models become more opaque, we have less quality, we have less control of what's going on. There's some nascent sort of work around things like white boxing and progressive neural nets, but the reality is all the weight is towards making things more accurate. So so the trust in the models kind of becomes much more about what we can do before and after the model's actually been built, and making sure the data's clean and we've got good quality data. And to Philip's point about unbiased.
Yeah, and the point I think Michael's point about critical thinking is, when you design that data set, how do you design all the different variants that you could actually think about that could actually give you that breadth and depth, I suppose, of actually testing all the different scenarios that you may want to get confronted with, or doing some test generation, random test generation. It's an interesting topic, because I think it's interesting. I know that when we started designing this session today, we wanted to build on the stuff that Philip was originally going to speak at when we were going to have the event in Moorgate, and obviously then, by adding James's session on and adding Ian's session on, I think that the theme that's come through all those three sessions is data is very important. It's kind of foundational in how you actually use as the input into the AI, and then obviously how do you have the right algorithms, the right capability and infrastructure to scale it. So it's been quite an interesting mix of presentations, I think, from that point of view. Has anybody else got any other questions they want to raise on the chat that we want to cover while we're here today? I notice Michael's on fire tonight. Notice that human intelligence repairs problems in inconsistent and invalid data. Machines cannot do this without human guidance. So that's the thing about, yeah, what do you use machines for, and what do you use humans as oversight and guidance to actually manage the overall experiment or the overall hypothesis testing. Okay, so I know we've run slightly over on the time. It's now 8:20 in the UK. And I know there's quite a lot of sharing going on in the chat from Michael. Thank you for that. So one of the things I just wanted to do was to just kind of wrap up from today. So I suppose what we're seeing is that in the overall software engineering world, that, you know, testing remains the last bastion for disruption. We've got an opportunity to make it easier, make it more progressive about how you manage that. I think the interesting thing tonight was actually seeing that obviously some of the fundamental stuff of 10, 20 years ago of actually getting your data right, using these new tools in the right way gives you the right results. Automation with intelligence, I think that's what came out of a number of the discussions tonight about how do you actually build the intelligence into that kind of infrastructure you build for doing automation, so you can actually help the humans that are actually working on the software engineering side to be more smarter of how they do it. And then the point which I think Michael was just saying about there is that obviously you can use the machines AI is here to stay and evolve. How do you leverage the power of the machines, but obviously with human oversight. But you've got to get the right foundations in place. One of the things that I think I took away from Ian's presentation was that there's a hell of a lot of tools still out there. How do you make the selection on that to get the right infrastructure and get the right architecture in place? Yeah. So what's next? As all the three speakers have mentioned, we're living in a kind of new world. Thank you very much for joining today's webinar, and I hope you got a lot of value out of it and learned some stuff as well. We're going to be continuing to schedule some future webinars. We'll put that on the meetup.com/LondonTAD. And as I mentioned earlier on in the session today, that if you have any interest in speaking, I know there's some people quite vocal on their on the Q&A and the chat a bit earlier. If you're interested in speaking, please send me an email, and we'll try and organise how we can get you involved in future webinars. But unless there's any more questions or chat, let's have a look. Let's have a quick look, final look. Lots of thanks. Yeah, thank you all for coming along. Thank you, Dennis. Thank you, Chris. Thank you, Michael, and thanks to all the three speakers: Philip from San Francisco, James from Auckland, New Zealand, and Ian from London. Have a great evening and keep safe. And obviously, given the current environment, it's obviously important to look after your families, and wish you all the best and see you soon. Thank you for joining tonight. Take care.